It is a true pleasure to be here. It is actually my first time in any type of AAPG forum, and I think the timing is perfect, especially for this topic. It is important to understand the challenges that we're facing, and I will be talking about some of the challenges. I know that you've talked about it earlier today as well. To understand the dilemmas, it's only when we do understand the wide variety of dilemmas that we also can go through a stable energy transition. And I emphasize the word stable. And I'll come back to what I mean with that. You as geoscientists, you are an important part of the solution. In fact, when I leave this session right now, I hope that that's the message that I will be leaving you with, that you guys are a very, very important part of the solution for the energy transition. Behind me here, I have a beautiful picture. It is the Hywind Tampen project. We delivered a PDO, Plan for Development and Operation, to the Parliament on Friday for this project. So it is sanctioned internally and will be approved by the government later on. What it shows is oil and gas together with renewables working together in balance. Windmills supplying power to 5 installations, 88 megawatts of capacity, and reduces then 35%, takes away 35% of the energy needs from oil and gas to those installations. Before talking about the challenge and geoscientists' role, I would like to say a few words about Equinor and how we are working with the energy transition. Some sort of a little bit of marketing, but it also is related to how to go through the energy transition itself. I really love our purpose, turning natural resources to energy for people and progress for society. You said the definition for sustainability. I think that this is a very important aspect to sustainability. Our vision, shaping the future of energy, we want to be taking lead. We don't want to be told. We want to form the future of energy ourselves together with our partners. And our portfolio, the Norwegian continental shelf, is still the biggest part of our portfolio. We have a growing international oil and gas portfolio. By 2030, our international portfolio will be bigger than our Norwegian portfolio. And then, of course, we have our new energy solution leg, where we are developing renewable solutions. And that is also growing, and we're investing more and more into that part of the business, together with also R&T funding for renewables and energy transition technology. So then, a lot of very nice words, and nice words only, or do we really mean something with this? And of course we do. So I have 3 pictures here showing parts of what we mean with this. You have Johan Sverdrup field on top there. It is a big baby of mine. I started working on that just after the discovery and all the way through to when we started cutting steel. A fantastic field. 4 installations will be becoming 5 installations later on. Production of 660,000 barrels per day when it comes on peak. And it has power from shore, giving it a CO2 intensity of 0.67. Fantastic in absolutely all different ways. Then we have Hywind Tampen, which I just mentioned, the previous picture that I showed. A lot of windmills to power up 5 installations. And then we have the latest part, the renewable part of our business. We got Dogger Bank awarded a month ago. That's 3.6 gigawatts of capacity. will be powering up 4.5 million UK homes when it comes on stream. So you have pure oil, you have a mix between oil and renewables, and you have renewables, a balance. And that balance needs to be present in everything we do, and it needs to be a stable balance throughout decades in this energy transition. And that balance is extremely challenging. We would, of course, have wanted to see that we would be relying less on fossil fuels than we do today, and could go through a faster transition with renewables, but it will take time. And I think these three pictures show that. If I mention this Dogger Bank, which is the world's biggest, it will be the world's biggest wind farm. 3.6 gigawatts, world's biggest wind farm. It will have something like 300 or 400 windmills. Comparing it with Johan Sverdrup, if you would replace that energy that field produces, you would need somewhere between 10, 12, 13,000 windmills. So you could say parts of our challenge is that oil and gas is extremely efficient. This picture I really like. It gets your thoughts running. You see where the people live. This is also the part of the world that's growing the fastest. I start wondering, how often do they have these type of topics in that region, between the average man in that region and the average woman? When they have this growth, where will that energy come from to support that growth? Will it be from coal? Will it be burning wood? Or will it be gas and renewables for power and hydrocarbons from the best type of fields that the world can offer? What we must ensure is, of course, that they do not go through the same development that the OECD countries have gone through. Our CO2 footprint has been and is very, very high. We have managed to decouple CO2 intensity from economic growth, and we need to do the same for that region. They, of course, deserve to leave poverty, to get a decent life, and that is also a huge part of sustainability. But they need then to get clean and affordable energy. Affordable is an important part of that. And as mentioned, they need to decouple their economic growth from CO2 intensity. This is a picture that shows parts of the same story. You see the growth where it is from 2016 to 2040, the primary energy demand, where that is. And you see in OECD countries it will be reduced, but in most parts of the world it will increase. And that increase needs to be sustainable. And I'll come back to what I mean with that. So I've talked about population growth, economic growth, and then the center there, the UN sustainability goals. All the 17 goals require more energy. We cannot solve for poverty without energy. We cannot give people decent work without more energy. So we need to have several thoughts in our head at the same time. Those that would like us to go through the energy transition very fast, that would result in a lot of the UN sustainability goals not being met, I would say. And the result of that, again, is unstable unstable energy transition. So you will have bigger differences between rich and poor, and those that have the worst conditions today will also be the ones that will suffer the most going ahead. So working for a company like Equinor, we try to have that balance. We try to solve for a lot of different issues. We try to have many thoughts in our head at the same time. We try to give the world the best type of hydrocarbons. We try to develop research and technology to give us the technology to help us through the transition. We try to develop our new leg with renewables. We try to do it all at the same time in a balance. A lot of us wants to change. We want to see change happening. That is the easy answer when you ask people. When you ask them, do you want to change? That becomes a little bit more difficult because it means changing your habits, having less luxury around you, doing things more difficult. But then if you want to lead the change, that becomes even more difficult. And I would say on a global scale, that is a huge challenge. We do not do that. Luckily, in pockets of the world and in different types of industry, we do that. We take that responsibility and we do a lot. And I think within the oil and gas industry, it does a lot. So for those that try to push us down, a lot would not have happened without that industry and the research and technology and the human capabilities and the experience that industry has, and of course the capital. In that transition and in that change, geoscientists come as a central part of providing very, very efficient energy to the world. And I know that one of my colleagues told me that you've basically seen this picture earlier today from other parts of the industry. So this is our view on the world, how the energy demand will look like going towards 2050. And I will spend just a few seconds on it. The trajectory for the oil starts at 100 and it goes upwards. That is, one scenario, and basically that is the scenario we're headed towards if things do not change from how we do things today. And then the bottom parts of that blue curve is what needs to happen if we're going to deliver on the Paris Agreement. And there is a scenario in the middle there as well. The difference there is huge, of course, as you see. And for gas, it's less huge because you really need gas to be part of the transition. But in both of those, both for oil and gas, there is a huge gap. For oil, 300 billion barrels, and for gas, 62 TCM. If we stop investing in oil and gas, that gap is what we get. And we need to fill that gap. Either with increasing production from existing installations, or with exploration. Or you could, of course, develop the stranded resources that the world has already discovered. And I would argue that there is a reason for why those resources are stranded. They require more energy, they are less CO2, they are more CO2 intensive, and they are less valuable. So for Equinor, exploration is much about developing your portfolio, high-grading your portfolio. For us, within our own company, we high-grade our own portfolio, but also for the global portfolio, exploration would high-grade the global portfolio. We need to find the right fields, and I'm not a geologist or a geoscientist, I'm an economist, so I look at you guys to do that. we need to find the right fields with the right profile that is easy to produce, meaning it needs less energy, it is not heavy. Hopefully it is also close to infrastructure, and later on we will be talking about carbon capture and storage, which is an important part of that transition and that balance. So that is what we need to do, and that is how we look at exploration from Equinor. And this is a very busy slide, but I'll simplify it. It shows the exploration history from the 1900 to 2015 or so, or 18, I think it is. So. And it shows the blue dotted line shows the discovery per well. The blue fixed line shows our success rate. And our success rate has, of course, increased. And it increases with better technology. And tomorrow you'll be talking a bit more about that as well, and I'll mention it later on. So with technology, we are much better at finding oil and gas, but we find less and less, which is the green parts here, what is the hydrocarbons that we actually do find. So we are, and the red dotted line is how many wells we drill. So we're drilling, the last 10 years or so, we've reduced the amount of wells dramatically. We are finding less per well, and we've been much better at finding, but very, very small volumes. So this is a huge challenge when we're trying to high grade our oil and gas portfolio. And I think what you'll be talking more about tomorrow, I think this will really help in solving that challenge. Digitalization, seeing geoscientists work together with data scientists, trying to unlock the value of data. In Equinor, we sit on an enormous amount of data, but basically we do not have the capacity to high grade that data and to get the most out of it. With the help of our partners and future partners, we're now working with IBM, we're working with Microsoft, we're working with several others to help us out with unlocking that value of our data and to cooperate with others in seeing opportunities that we couldn't see before. And as I said, I know that this will be covered tomorrow. And then we have this picture. I think this was actually shown here last year. And I really liked it, so I brought it with me again. And it shows the mountains that you see there, they say something about how much does that part influence CO2 intensity. So the bigger mountain, the bigger influence it has on the CO2 intensity of a certain discovery and a certain field developments. And what you see is the subsurface is what really, really matters. If you get that right, then everything else becomes much easier. If you get that wrong, then everything else becomes much more difficult. From last year to this year, I would say that these mountains should actually change a bit. Of course, you have gas being flared. We're trying to reduce that. Onshore, offshore, I would actually argue it doesn't really matter if as long as you're close to infrastructure, you can solve for that. But the development concept at the end there, I would say that the opportunities that we see today, that could be a much bigger part of the influence in any field. So if you have a field with a high CO2 intensity, you could reduce for that with wind, as we did for the High Wind project. You can reduce for that with carbon capture and storage. So that part, I think, is changing as we speak. So basically, what I want you to leave you with is that our strategy, high value, low carbon. We want to discover, we want to target fields that can give us those two things. And luckily, they are interlinked. If it is low carbon, it is usually also high value because it needs less energy, it is normally close to infrastructure, and it can provide high value for us. And you need to have that as part of your energy transition because of what I said to begin with, that a barrel of oil or a BCM of gas is a lot of energy, and it is extremely difficult to replace that with any other type of energy source. As of today, we need time to solve for that, and that will take time. It will take decades. And in the meanwhile, we need to solve for high grading our portfolio, changing out the worst type of discoveries that are stranded and just laying there with new, better hydrocarbons, and also for carbon capture and storage, and for other types of technologies at the same time. Our goal at the end of the day, energy for people and progress for society, which I would say is essential for any sustainability goal. Thank you very much.